Take a look at the universe. The phone you see, your plants, the animals, bed, food, or even the chair you're sitting on. All these things are made up of matter. Now, what is matter? Matter can be defined as anything that has mass and occupies space. Now, you may be wondering, everything basically that you're looking at right now is actually matter. For example, take a look at the door, the shelf. All these things are matter. They are termed matter because they actually occupy space. You can see that they take up space, and you can also measure their mass. For example, you can say the door is 3 kilogram, 1 kilogram, 10 kilogram. So that's the reason that they are called matter. They have mass and they occupy space. Everything that you're looking at seems to be solid. However, matter have different states. So let's talk about the different state of matter. You notice that from the picture, the diagram that you can see, that is actually a solid. Ice, water that have actually solidified. So matter has a solid state. What is the unique thing about matter in the solid state? They have particles that are tightly packed together, vibrating about a fixed point. That means the particle does not move, and they have strong attractive force. Please take note of that. Did you notice that the solid actually have fixed shape? Their shape is actually definite, and they have a fixed shape. Example of matter in a solid state is actually solid iron, a block of ice actually present in your screen. The second state of matter is the liquid state. Now take a look at the picture. You realize that the liquid in the cup does not have a definite shape. However, it takes the shape of the container. Liquid particles are close, but not as tightly packed like that of the solid, and they can actually glide or slide over one another. It should be noted that the force of attraction in liquid is quite weaker than or far weaker than that of the solid. The third state of matter is the gaseous state. And in the gaseous state, you notice that there is no definite shape or volume. Now take a look at the diagram. You realize that the gaseous particle actually expand to fill the entire container. They are distance apart. That means they are far apart from each other and they move fast and randomly, hitting, colliding with the wall of the container and with one another. Now note that the force of attraction in the gaseous state is very weak. Now let's take a look at the summary of the state of matter. Take a look at the solid. You notice that the particle there is rigid, has fixed shape, and it has fixed volume. The particles are actually tightly packed. Now, take a look at the liquid. You realize that the liquid is not actually as rigid as the solid. It has fixed volume but no fixed shape. It actually takes the shape of the container. As you can see, the liquid is taking the shape of the container, while the last one is the gaseous state. It is actually not rigid, it has no fixed shape, it has no fixed volume. The gas particles are just expanding, filling the whole of the container. The distance between the gas particle are far apart, and the force of attraction in the gas particle is actually very weak. Remember, the force of attraction in the solid is stronger than the liquid, and that of the liquid is stronger than the what? The gaseous state. Let's take a look at the change of state. Matter can change its state from one form to another. Remember, we have three states: the solid, liquid, and gas. So a matter can change from solid to liquid, or from liquid to solid, from liquid to gas, or from gas to liquid. This change is actually driven by either addition or removal of heat energy. When you heat water, for example, your ice, for example, it can change to liquid. And when you heat or you put the liquid in the freezer or in the fridge, it changes to solid. So this change is driven by either addition or removal of heat. Take a look at the diagram above. When you heat the solid, it can change to the liquid state. This process is called melting. You can see from the diagram above. However, when you put this liquid in the fridge or when you reduce the temperature of this liquid, it can change to back to solid. This process is called freezing. Now, note that when you heat this liquid, it can change to vapor. This process is called evaporation. Or while you reduce the temperature of this vapor, this water, gaseous state of water, it can change back to liquid. This process is called condensation. Note that some solid state can actually change to gaseous state directly. This process is called sublimation. Why some gaseous state can change to um, solid state directly. This process is called deposition. Please take note of that. Let's talk about the properties of matter. As a scientist, matter can be described by their various properties, and these can be physical properties of matter or chemical properties of matter. Remember, scientists actually identify matter using their properties. Take a look at the wood or even the iron that you can see on your screen. How did you know that it's actually an iron? You know the color, you know that it's a metal. So these characteristics that you use to identify these things are called properties. As I mentioned earlier, properties are divided into physical properties and chemical properties. Let's talk about the physical properties. Physical properties are those characteristics that you can observe or measure without changing the chemical nature or identity of the substance. For example, you can observe the color of the iron, you can observe the melting point, or you can measure the melting point of water, the boiling point of water. You can even smell a particular substance. So those are actually physical properties. And the physical properties are divided into two or into two categories, namely the intensive and the extensive. Some properties actually depend on the amount, and such properties include the mass and volume. They depend on the amount of matter, while others do not depend on the amount of matter. These are the intensive properties. Example include the density. Color, for example, does not depend on the amount of anything. Color remains the color. So take note of that. Let's talk about the chemical properties of matter. Now, chemical properties are actually those characteristics or properties involved when matter undergo chemical changes to form new substance. These characteristics or properties are only observable when the matter undergo chemical changes, transforming into a new substance with a different or a new composition. Example of chemical properties include flammability, reactivity. You see rusting in iron. It's actually a chemical change. You can see the burning of the wood, flammability, the burning of the wood. This is actually a property, flammability. Now, let's take a look at water, stone. Are they flammable? Can they burn? No. So, wood, for example, petroleum products, they are flammable. So, it's actually a property, but this is actually a chemical property. Now, the wood changes from the normal to wood to the ash that you see. So, these are actually flammability is actually a chemical properties. Reactivity, acidity, basicity. These are chemical properties. Let's talk about physical and chemical changes in matter. Physical change is one which is easily reversed and no new substance is formed. A change that actually alters the state of the matter or the size, shape, without changing the chemical constituent or composition of that matter is called a physical change. Two key important points to know a physical change is the fact that they can easily be reversed and no new substance is formed. Now let's take a look at the diagram. You can see the ice. Ice can be turned to liquid and be turned back to ice easily. See the boiling water, you can heat your water and form vapor, and vapor can condense and form the water back. Now those changes that actually occur and result to the matter changing state, maybe from liquid to solid, from solid to liquid and all that, they are actually physical change. Another change that should be noted is those changes that can easily be separated by normal physical methods such as you mix salt and water or salt and rice, oil and water. You can use some separating techniques to actually do the separation. So those are also physical what? Change. Magnetization and demagnetization is another physical change. Note that in physical change, two things, key things, easily be reversed and no new substance. Even in that wood that you're seeing in your picture, the splitting of the wood, no new substance is formed. Now let's talk about chemical change. Chemical change is a change or is one that is not easily reversed and a new substance is actually formed. In chemical change, one substance is actually transformed from another. Now, take a look at the diagram you can see on the screen. You can realize that the wood during burning is transformed to ash. This cannot be easily reversed, and a new substance, ash, is actually formed. Fermentation process is also another um, chemical change. Rusting of iron. Numerous examples of chemical change in nature are actually occurring every day. This is actually the end of this lecture. Thanks for watching.